Hi all, in this video we're gonna do a X-ray pneumonia classification and 3D CT scan. So we're gonna classify normal versus pneumonia and 3D CT scan volume rotating, and we're gonna plot the mal accuracies. So can a single deep network diagnose pneumonia from X-rays and even detect COVID-like lesions in a 3D CT scan? In this video we're gonna build two keras pipeline, a 2D CNN on chest X-rays and 3D CNN on volumetric CT data. So let's get started. So first we'll um, load the required libraries, and then we read the images and file paths from separate TF records, zip them, and then parse each JPEG into 180 cross 180 RGB tensor. We extract labels by checking if the path contains pneumonia, and then we're going to shuffle the split with 4200 for training and rest for validation. Then we're going to cache them and batch and prefetch to maximize GPU throughput. So our CNN stacks separable cons with batch knob and max pulls, and then three dense blocks with heavy dropout. We compute an initial bias to offset the class imbalance, 3.8K for pneumonia versus 1.3K for normals, and class weight into model fit. After just one epoch, you get 75% of training accuracy and 86% for validation, with precision around 0.93 and recall rate greater than 88%, which is critical for catching true pneumonia cases. Plotting was train was validation accuracy. So here we can see the classification, classified pneumonia or normal accordingly as per the images. So this is the model precision, recall and accuracy and model loss. The test set accuracy holds around 72%. Since recall is high, the model errors on the side of lagging potential pneumonia, which we may prefer in medical setting. For each image, we show model confidence with how much confidence it's predicting. Therefore, 60% pneumonia was 40% normal, giving clinicals a soft label. And then next moving on to 3D CT scan. We download two zips, one which has 100 CTs normal, CT0, we label that as, and 100 abnormal, which which is CT23, and extract them locally. We read each with NI Babel and clip units to minus 1000 to 400, and we're going to normalize to 0, 1. Then rotate and zoom to uniform 128 cross 128 grid using zoom, and then we stack 140 volumes, split 70 by 70 into training and validation sets, and then build TF data pipelines, which is random 3D rotation augmentation via TF.numpy function, and add channel dim with batch size of 2, and we're going to prefetch them. So our 3D CNN stacks are for convolution 3D to pool and then to batch norm groups, then a global average pool. So a 512 unit dense layer, dropout and sigmoid head. So here our total parameters are around 1.35 million. So it easily fits any modern size GPU. And then we're going to compile with Adam and an exponential LRDK, then train up to 50 epochs with early stopping on validation accuracy. So the validation accuracy in our case peaks around 72% after 40 epochs. We saw some over and undershoot due to small data, more augmentation or transfer learning could help. So here we can see that validation performs plateaus or dips, and then we load the best checkpoint, run one volume through, and get around 90% of abnormal on a held out scan. Below we visualize the sliced 30 to correlate prediction with liaison patterns. So here this is the end-to-end cross pipeline for diagnosing pneumonia in both 2D and 3D scans. Thank you.